they taught us that the distance between the Earth and the Sun in the closest point, that is called the perihelion, is of 147 million kilometers, and the distance between the Earth and the Sun in the farthest point, in the aphelion, is of 153 kilometers. But the teacher also told us that if we want to know the distance between any point in the orbit from the Earth to the Sun, there's a formula, but I don't know which one is, and I'm interested in knowing.
Well, I can explain you, but first, do you know what is the ellipse of the Earth around the Sun?
No.
Well, ellipses are classified as conic planes, and they have a specific formula so that you can know the distance from any point to its center. I remember when they taught me this in school, and well, let me try to remember so I can explain.
Based on the equation, we put a graph to better understand the problem. Information that we know is that perihelion is close to the Sun with a distance of 143 million kilometers. And aphelion, which is farther from the Sun, that has the distance of 153 million kilometers.
Well, to complete the diagram, to having an idea and organize your ideas for solving the equation of the Earth around the Sun, you first have to find the center of the ellipse. As it is mentioned in the problem, the center of this ellipse is located at the center, the origin of the graph. It means that the coordinate will be 0, 0. Then, in the same problem, it indicates that the vertices of the graph are the aphelion and the perihelion, which means that this point and this point have to be with the same y value as the center. So we classify that the vertex number 1 is going to be in this side, in the perihelion, and the second vertex is going to be located in the aphelion. Then, to find the covertices, we should know that it's from here and here approximately. The covertices have to have the same x value as the center, so they have to be here in these 2 points. To solve it, we located the first covertex here and the second covertex here. And well, finally, in the problem, establishes that the Sun is at one focus of the graph, which we classified as focus 1. And that we have to have another focus which has to be at the same distance from here to here than from here to here. So here it's the second focus. And these ones are the specific points of the graph.
For this, we have to get the values of A, B, and C. To get A, we have to add the values of 147 million with 153 million. That would give us the answer of 300 million. After that, we had to divide by 2, and that would give us 150 million kilometers. To get C, with the value of A, we subtract it with 147 million. That would give us the value of 3 million kilometers. To get B, now we have to use this formula. B squared is equal to A squared minus C squared. Since the values of A squared and C squared are very big, we're using scientific notation. So the answer would be Now for this, we have to use the square root, for this, and the answer for that would be $149,969,997 kilometers. That is value B. These are the three values, A, B, and C.
After we get the values of A, B, and C, we can graph the ellipse.
The center is going to be point 0, comma 0. The vertex 1 is going to be A, comma 0. And vertex 2 is going to be the negative A, comma 0. Then the co-vertices is going to be 0, comma B. And co-vertex 2 is going to be 0, comma negative B. The foci 1 is going to be C, comma 0. And foci 2 is going to be the negative C, comma 0.
Now, to get the major axis, it's 2 times A, which gives you 300 millions. The minor axis is 2 times B, gives you this. To get the eccentricity, it's C divided by A. And it's almost a circle, so the eccentricity is 0.02. And the lateral recta is 2B squared over A, which gives you this. And after that, we can graph pointing all the points. To get to the formula, what we did was to write A to the square, which gives you this. Because it's a really big number, you can represent it in scientific notation.
Also, B raised to the square, that gives you this number also in scientific notation. And that's it.
And well, did you understand the formula for getting the distance from the Earth to the Sun in
Yes,
Bitcoin?
thank you, Dad.
Well, you're welcome.